morning. Glad to see everyone's back today. We're going to begin each class section answering questions over the previous homework. So we covered 2.1 and 2.2 on our last class meeting. Does anyone have any questions about the homework for 2.1 or 2.2? On 2.1 or 2.2? Yes, be glad to. 25 on 2.2. It says change to a percent. The problem that you're asking about is 7/12 the fraction. Yes, we're going to take 7, divide it by 12. I'm going to get my calculator out. I need to first, I like changing that to a decimal to begin with. So I'm going to go 7 divided by 12 in my calculator, and I get, oh, and we didn't talk about that. That's very good. 0.58333, right? And that 3 goes on and on continuously. How we're going to write that is 0.583 repeating. Does that make sense? If we change that to a decimal, we're going to move to a percent, we're going to move the decimal point 2 places. Which direction?
Right.
To the right. I like that answer. There's another way we can write that. Does anyone know the fraction for 0.333 repeating?
1/3.
We're going to see if we can zoom in. Yes, and we can also, this is a very good answer. Another very good answer. I'm sorry, I don't want that decimal point there. Would be to make it 58 1/3. I think both of those. They actually mean exactly the same thing, and they're both very good answers. So if you know the decimal equivalent of a third is 0.333 repeating, we'll take that. If not, we'll just do 0.3. The bar over it says that repeats infinitely. Did that get that question answered? Is there another one?
I have a question.
Okay.
In 2.1, we were going over the maze and all that. What I didn't understand is how do we come up with the sentences? Is there a certain formula for the sentences that we had to write down about the problem?
No, all they wanted you to do in 2.1 is to come up and see if you knew what the base was. We're actually going to work with those sentences today. Okay. That's really what we're going to do today. Okay. We're going to define each part, and we're going to come up with a formula. And we're actually going to use something called a proportion to solve those. We're not going to use the number sentence maybe that you're thinking about.
Okay.
Okay. Who else had a question on 2.1 or 2.2? Yes?
On 2.2, would you work number 27?
Yes. 27 is 3 11/20. There are 2 ways to do that. The way I probably would do that is just change the fraction to a decimal. I would do 11 divided by 20 in my calculator and get 3.55. 11/20 is the same as 55/100. Now you've got a decimal. We're going to change it to a percent. That's going to be 355%. Another way of doing that, and I think someone up to the front here talked about doing that in our last class section, is you can convert the entire mixed number to an improper fraction by taking 20 times 3 and adding 11. And then in that case, you'd get 71 divided by 20. And if you did that, you're going to get 3.55. And does what 355% means make sense? It means lots more than 100%. More than whole, 3 times more. And I always use that as a shopping experience. If you thought you were going to spend $100, it would mean you spent $355. Another question? And can everyone see what we're doing? Is that going to work okay on the screen? Okay. Anything else on 2.1, 2.2? Again, we will begin every class section answering any questions that you've got. Then we're ready to switch and go to 2, 3. Someone asked the question, are we going to turn these into number sentences? And the answer is yes, and we're going to identify the 3 important parts of every percent problem. On 2, 3, it's called basic percent problems, and we're going to learn how to solve them. You've got your class notes, and you can follow along. There are 3 items that you need to identify in every percent problem. One of them is the base, which we talked about in 2-1. One of them is the rate, and the last one is the part. If we're talking about the base, we're talking about the starting point, the whole amount, the original amount. Usually, the base is associated in a number sentence with the word of. Usually, okay? The rate is usually associated with the percent, and the part is usually associated with the word is. We're going to use R to represent the rate. We're going to use P to represent the part. We're going to use B as the letter to represent the base. Every time we work a percent problem throughout the entire semester, what you're going to need to do is clarify in your own mind what each of those 3 items are. Generally, you have 2 of them, and we're solving for the 3rd one. When you have 2 of those 3 letters identified with a number, then you can solve for the 3rd number. Is that all right?
I got a question. What was rate again?
It's the percent.
Okay, thank you.
If we use the number 25%, then the rate is 25. If it's 50%, then R is 50. We are going to not use algebra. Algebra is not a prerequisite for this course. Some of you are going to find that in your background, you've got a way that you algebraically solve those problems. But we instead are going to use proportions, and I'm going to encourage you to use proportions not only today, but throughout the rest of the class. Just come on in, sit down. And we are going to solve proportions throughout the rest of the semester. It's very important, even if you know another way to solve these, that you put everything into proportions, because as we continue on throughout the semester, we are going to use a proportion for everything we do. We are not going to use algebra. I always get comments that say, but I know how to do it this other way. And I keep thinking, that's great, but you can't do everything we're going to do all semester, so come along today, do all your homework using proportions. I think you'll find it's very powerful, and you'll find that you will not get confused later on. Okay? The proportion that we're going to use looks like this. The R over 100 equals the P over the B. That says the rate over 100 is equal to the part over the base. When we solve a proportion, we cross multiply. And what we're going to do is take the very first example here that says, what is 15% of 180? It says, what is 15% of 180? We need to ask ourselves, what 2 of the pieces do we have, what 1 piece is missing? Well, first of all, does anyone see one of the parts that we have? We're looking for P, R, and B. Someone said they see the base. What is the base? 180. 180, and look at it. It's associated with the word of. So we're going to put 180 as the base. Do we have the A, or do we have the P, or do we have the R? We have the R. Very good. What is the R? 15. And we want to leave it as 15%. We don't want to change it to a decimal. What we're going to say is the rate, 15, compares to 100, proportionally the same as the part compares to 180. Once you've got the proportion set up properly, the key is you cross multiply. I'm going to show you how we do that. You say that's 100 times P equals, and then you cross the other way, 15 times 180. Get out your calculator and tell me, what is 15 times 180? 2,700. Then you divide both sides of that equation by whatever's in front of the unknown. What's in front of the p? 100. So we're going to divide both sides by 100. P equal 27. Very powerful. We can do some very complicated calculations later on using proportions, okay? You will get to the point where you'll go 15 times 180 divided by 100 in one keystroke on your calculator. You're not going to need to put down every step. Is that all right? Then what we're going to do is kind of go quickly through 2, 3, and 4, see if we can set them up. And then we'll start looking at some application problems, because that's our goal in here, is to not only do the math, but to be able to relate them to real-life business situations in the real world, okay? Every time we're going to start out with that same proportion. We're going to say R over 100 equal the part over the base. Now, at the top of this page it says finding the part. So guess what the problems on this set of examples are always going to be looking for? P. So we're always going to be looking for the part. That's right. Problem 2 says, what is 3.9% of 700? Everyone got it figured out? Push the pencil. What goes under R? 3.9. The 100 always goes underneath the rate. We're looking for the part. What is the base?
700.
And how would we have known that that was the base? Because it says of 700. 700 is the original amount. What we're looking for is the part. Is the part we're looking for going to be larger than 700 or smaller than 700?
Much smaller.
Lot smaller. Why do you think that?
Because you divide it by the 100.
I'm looking for 3.9%.
Percent. Right, so it's a very small amount. And it's proportional. For every 100, only 3.9. So if there's 700, it's going to be much smaller than. It's proportional. That's kind of the power of the proportion. So we're looking for P. We're going to cross multiply. We're going to go 100. P equal 3.9 times. Can I put a dot up there that indicates multiply? 700. Then I'm going to divide by 100. Divide by 100. P equal. And do you see we can do that in our calculator? Go 3.9 times 700 divided by 100 equal. What did somebody get as an answer?
273.
Okay.
27.3.
27.3. I'd like for you to go ahead and work on problem 3 and problem 4. Take just a minute to do that, and then I will get them on the Elmo, okay? Identify what the rate is, identify what you're looking for, identify the base.
What page is this on?
On your handout, on your notes. Do you have your notes today? That's where you should be, is on the notes. And this is what I needed to be able to do. Can you see back in the back now? Okay. I've got example 3 and 4 worked here on my class notes. Did everyone end up with 1.05 on problem 3 and on problem 4, 15? Okay. We're going to do a couple of application problems next then. First one is about sales tax. Sales tax is a percent of the amount of sales. The sales tax is actually the part, and how much you pay for an item is actually the base, and the sales tax rate is the rate. We are going to find out how much tax should be charged if the rate is 6.5% and the amount of the purchase is $400. That would be a pretty realistic sales tax amount. The R would be equal to 6.5. The base would be 400, the amount of the sale. Once again, we would be solving that for the part. We're going to put 6.5 over 100. This is proportional to P over 400. Cross multiply. And you're starting to think, I always divide by 100, right? That's not the case, so don't get in that habit. Okay. It is when we're finding the part. And we ended up with $26 in sales tax. So if you purchased an item with a 6.5% sales tax rate that you paid $400 for, the amount of the tax would be $26. And some of you have other ways that you would have worked this problem, but do you see how we work at using proportions? The last problem here says a company employs 750 people, of which 60% are women. How many women work for the company? What does 60% mean? 60% are women.
60% of all 100 employees.
Out of every 100 employees, 60 of them are women. So we set up our proportion. 60 are women out of every 100 employees. That's proportional to the part that are women compared to the base of 750 employees. So the total amount of employees is 750. Cross multiply, divide by 100. We end up with 450 women. What if I wanted to know how many were men? Because we're going to do that soon.
Subtract.
What would I subtract?
Subtract 450 or 750 from 450.
That's right. If I wanted to know how many of those were men, I would take the total workforce, which is 750 people, subtract the women, which would be 450, and I would end up with the total number of men. Great. All of these problems that we worked, we were finding the part. Top of the next page. Let me see if I can find my spot. Finding the base. Here we're going to find a different letter in our proportion. Instead of finding the part, we're going to be finding the base. We use exactly the same proportion, only we're solving for B. Generally, the part is associated in this problem with the word is. 9 is 29% of what number? Of is generally the word that's associated with the base. So we're looking for B in this case. Questions? Does that make sense? Set it up. We're going to go 29. The rate is to 100, proportionally the same as 9. The part is to what base? We again cross multiply. We get 29b equal 9 times 100 or 900. Divide by the number that's in front of the b, which is not 100 in this case. It's 29. $31.03. Questions? $2.5 is 0.2% of what number? What are we going to use for rate? For R? 0.2. What are we going to use for P?
Or 2.5.
2.5. And what are we going to use for B? B. That's what we're solving for. Again, put it in your proportion, cross multiply. When the words in the problem say what is, we're looking for the part. When it says of what number, we're looking for the base. I ended up with 1,250. Okay, let me move these. This one's a little unique. 5 is 1/4% of what number? What are we going to use for R? 0.25, that's right, 0.25 over 100. I like using that decimal instead of the fraction. So I've got 0.25 is to 100 proportionally the same as 5 is to B. We keep doing the same thing. We cross multiply. We divide by what's in front of the letter that we're looking for. We call it the unknown. We end up with 2,000. Is everyone with us, or do we have questions?
I have a question.
Go ahead.
On number C,
Yes?
when you multiply 500 by, divide 500 by 2.5, what did you say that?
0.25.
0.25, okay.
We're taking, when we cross multiply, we have 25 hundredths B equal 500. Let me scoot it over. Then we're actually going to be dividing by 0.25 here, dividing by 0.25 here, because 1/4 is 0.25. And then you'll get 2,000. Applications that involve looking for the part. Says, I have a 6.5% sales tax. Let me see if I can get this a little square in here. And when I left, the tax that I paid was $45.50. That's the part. How much was the original price of the item that I purchased? When I look at purchase price and I'm looking for what the problem is asking for, I know that tax is the part and the base really is the purchase price. So the 6.5 goes into R. The 45.5 is the part, and the B is what I'm looking for. Set it up, cross multiply. The items that you purchase cost $700. And it should be that the part, $45.50, is smaller than the $700 because we're only paying $6.50 for every $100 that we purchase. Because the proportion works, but it should also sort of feel like there's a balance and kind of have a comfort level there. One more application problem then. I'm going to move this up again. The yearly maintenance costs of a building are 1.5% of its value. So you've got this large complex of some sort, and we're paying 1.5% for maintenance. If the maintenance costs last year are $3,500, what is the value of the building? So the maintenance costs represent P, part. What we're looking for is B. Is this going to be a really large number or a really small number?
Big number.
It's going to be a very large number, and you should start feeling that when you get numbers, whether or not they're correct or not. So we're going to set that up. What did somebody get as an answer?
233,000.
Can everyone see that? We ready to move on? Great. So far, our proportion problem had 3 unknowns. One was the part, one was the base. The other unknown is the rate. Our last set of examples then deal with finding the rate. What's associated with rate? How do we know we're looking for the rate? When they say what percent, right, or what rate? $25 is what percent of 75? I absolutely know I'm looking for the rate. I need to determine then, is the 25 and the 75, which one's part and which one's base? 25 is part. How come you know that? Of is in front of 75. So of 75 says that's the base. 25 is the part. Now the part doesn't always have to be smaller than the whole, but in this particular case it is. So we're going to set up our proportion. We're going to leave our R over 100. We're going to put the 25 over 75. Anyone having any trouble, I will come around and help you if there's any thing that's not working. Are we ready to move on? How's my back row? Can you see okay back there? Okay. Problem 1b, 1300 is what percent of 52? Let's talk about this one for just a minute. What do you think the part is? 1300, but it's the bigger number. It's okay, right? What does that tell you what kind of a rate we're going to have when we finish?
Big
We're going to have a big number. It's definitely going to be bigger than 100%, right? When the part is larger than the base, we're going to have over 100%. That's exactly what you need to anticipate. 52 is the base, 1300 is the part. We ended up with a very large number in this case. And I asked the question, what does a large number mean when it is a percent? It means that the part is greater than the base. What we ended up with as a part is larger than the starting point or the original amount. Square this one up here. 1.25 is what percent of 30? I sound like a broken record. What's the base? What's the part? We're looking for R. This is so you can go home and do your homework, because you're going to have problems that look just like these. I see the word is, and most of these we can put into sentences so that they read with of by the base and is by the part. Has everyone got that one set up? Anyone not get 4.16 repeating? What are we doing?
On number C,
Uh-huh.
I got 4.5. I don't know how.
Did you use a calculator?
No, I didn't use it.
What do you have is the part?
1.25,
And what do you have is the base?
100.
Do you look at the screen? We've got R over 100 is equal to 1.25 over 30. Do you see where it says of 30? 30 is the base?
Okay. 30 is the base, I'm sorry.
Right, okay. And then if you cross multiply, you should get 30R equal 125.
Okay.
I've got 125 divided by 30 then. I always divide both sides by whatever's in front of the unknown. And if you put that in a calculator, it should be 4.16 repeating.
Okay.
And I would encourage you to bring a calculator to class every day, because we are going to continue to just work on problems, and we don't end up with what I call clean numbers. We're going to end up with numbers that we intend for you to use a calculator in this class. We want you to be calculator competent, and I will help you with whatever calculator you've got. I'll come around and personally work with you. We want you to, we will use a calculator on every test. We will use a calculator on the final. So I encourage you to get a calculator that you like and work with it, keeping in mind that by the middle of the semester you must have the financial calculator, but you can use any calculator at this point that you want, any calculator that you've got. But most of these numbers are not going to be numbers you can do in your head, or they're going to take too long to do in class if you don't have a calculator. Yes?
Graphing calculator, will that work for that financial calculator there, or is that just one specific kind?
What I'll talk to you about that after class. It is possible, but you will be responsible for figuring it out. I teach with this, but it's very possible to do. You'll just have to get some help in the Math Resource Center. So let me talk to you about that one, kind of give you the ins and outs of it right after class. So the answer is yes, but you're responsible for learning it. Application. Is that all on the screen? It says, I walked away from the store. I looked at my ticket. $5.80 was charged for taxes. My purchase was $79.95. I'm wondering, what tax rate are they charging me? If I give you the part, and I give you the base, I give you the tax, I give you the purchase price, can you tell me what rate I've paid in taxes? And the answer is yes. Set it up in a proportion. Part is 5.8 or $5.80. Base is 79.95. Generally, once you get it set up in the proportion, the hard part's over. Figuring out what numbers to put in the proportion is the hard part. Doing the cross multiplication and division becomes very routine. I ended up saying that it's a tax rate of 7.2545%.
Why didn't you round it off to 7.25?
They really don't do that. Lots of times tax rates are more than 2 decimal places. And if we were rounding, that would be fine, but tax rates really can be many digits long.
So mine goes many digits long, so how many digits
Oh,
would you
you're
like
saying
to-
it didn't, okay, let me put that in my calculator. I understand your question. She's saying it did not end at that number. And why did I pick to round it there? That's a very good question. I didn't pick to round it there for any particular reason. I guess 7.25. I kind of don't like rounding to 7%. I like carrying it out at least to the hundredths, but
What answer do you want? You want it into the fourth place?
and I'd be happy with at least 2 digits long. What I would not be happy with is 7%. Yes.
Whenever rounding or whenever dealing with money, don't you round up?
That's another very good question. In the grocery store they do, right?
Well, I thought everywhere they did.
And he's asking the example, if something was 3 for $1 and it ended up costing 0.33333 repeating cents per orange, do we round it to 34 cents? Sure. Those are kind of, I'm kind of happy with 0.33 repeating also.
So either or.
I don't think either one of those are wrong. Generally, for a test or in the book for homework, they're going to tell you how many decimal places to carry things out to. An investor earned $475 on an investment of $8,500. What was his rate of return? Again, what's the part? What's the base? The investment is the base. The earnings are the part. We want to come up with a rate of return. Can you see there's many applications for this basic percent problem, right? This one, once again, is a long repeating decimal. I've actually given the answer as 5.588. I would be just as happy with 5.59. I would not want 6% as that. I would not want that rounded up to a whole percent. Give me at least a couple of decimal places. Next problem. It says this year's sales are $450,000. Last year's sales were $425,000. How much is the rate of increase? Look at your hint here.
It's a big number.
I want to calculate the percent of increase. There's a trick in this problem, and you need to see the trick. You can't always use just the numbers that they give you. You sometimes have to make additional calculations. What's the base? 425,000. Last year, the original amount. Now here's the trick. What's the part?
25,000.
Somebody's saying 450,000. Somebody's saying 25,000. Somebody else is saying 25,000. We want to know the percent of increase, the rate of increase. So what do we need? We need the amount of increase. They didn't give us the amount of increase. They gave you last year's total, they gave you this year's total. You have to first calculate how much the increase was, which is where those people are coming up with, $25,000. So P is 25,000. They didn't give you that, but they gave you the number so you could calculate it. Okay. It says change is the part. So we have to calculate the change. Think. First, you must calculate the amount of change. Here we go. I'm going to make sure this comes up on the screen. We've got 450,000, which is the new, 425,000, which is the old, which gives us change of $25,000. Our proportion then says R over 100 is proportional to 25,000 over 425,000. Is anyone having any trouble putting these in their calculator? What I'd like for you to do then, if you've got your book, is get out your book, and we'll finish our taping, and we're going to take about 10 minutes for me to come around and help you set up and get started on your homework, okay?